Hi folks, welcome to 6.6, the inverse trig functions. This will be the last section in our chapter 6, just so you know where to stop studying for the chapter 6 exam. Okay, so let's get started. 6.6, the inverse trig functions. So before we talk about the inverse trig functions, I thought it would be useful to go back and think about what our main trig functions are, what the reciprocal trig functions are, and then talk about the inverse trig functions. So let's go ahead and get started. Our main trig functions. I think we all know those to be sine of theta, which we can think about is opposite over hypotenuse in a right triangle. We can think about cosine of theta, which is adjacent over hypotenuse in the right triangle. Or we can think about tangent theta, which is opposite over adjacent. Now, as far as how those relate to the unit circle, we can say that sine of theta is the y values on the unit circle, cosine theta is the x values on the unit circle, and tangent theta is y over x in our unit circle. And that'll be particularly helpful in today's lesson. So let's take a moment and go back to the reciprocal trig functions. Now we've seen those before in our recent units or recent sections. And so when we take the reciprocal of sine, we actually get cosecant theta. And if it's the reciprocal, it's not going to be opposite over hypotenuse, but it's going to be hypotenuse over opposite. And we can say that that is the reciprocal of the y value, or 1 over the y value on the unit circle. Well, what about the reciprocal of cosine? The reciprocal of cosine is secant theta. And instead of saying adjacent over hypotenuse, is going to be hypotenuse over adjacent. And instead of saying x, we can say 1 over the x values of the unit circle. Our final reciprocal trig function is the one for tangent, and that's going to be cotangent theta, which is not going to equal opposite over adjacent, but adjacent over opposite. And it's not going to equal y over x, but it's going to equal x over y. So those are functions that we should be fairly familiar with at this point. And now we're going to talk about our last trig function type, which is the inverse functions. So these inverse functions are different than the reciprocal, and I think that's easy to confuse, so I just wanted to clarify it here. The inverse trig function for sine is not cosecant, but it is inverse sine, or sometimes you see it written arcsine. And those are the same thing, and we read them as inverse sine or arcsine. Now, the inverse function for cosine is cosine minus 1, or we could also say arc cosine. And the inverse function for tangent is tangent with a minus 1, or arctan. Now the thing about the inverse functions is all three of these actually just give us an angle. So if our question says arcsine or arccosine or arctangent, then our answer should be an angle. Okay, so let's take a look at some functions, some ideas around inverse functions. So just to base what we're going to learn about inverse trig functions in something that's true for all types of inverse functions. Okay. So, relationships between inverse functions and functions. Y is an inverse function if and only if x equals f of y, where x is the domain of the inverse and y is the domain of f. Now that's a fancy way of saying that the domain of the inverse function is the range of the function, and that the range of the inverse function is the domain of the original function. And some of us might know that more as when we think about inverses, that we switch our x and y's. And that's precisely what we're doing. When we switch the x's and y's, we're switching the domain and the range. And that if the point AB is on the graph of f, if and only if the point BA is on the graph of the inverse function. So again, this sixth statement says the same thing. Now, more significantly though, the graphs of the inverse and the original functions are reflections of each other through the line y equals x. Now, these two that I kind of skipped over, 4 and 5, I want us to keep in mind that this is only true. So if I do the function of the inverse function, I should get my original value back out. But that's only true if it's in the domain. And we're going to start to see some domain restrictions. So I don't want us to think that's true for all of our inverse trig functions. Now, similarly, if I take the inverse of the function and of y, then for every y in the domain of f, that's going to be true. So again, it depends on what's in the domain and what's not in the domain. Okay, let's take a look at our inverse trig functions. So we're going to start with our sine and inverse sine. So on the left here, I have the graph of sine. And this should be a graph that's familiar to us. And if we think about some important features of sine, we know that our domain for sine is all real numbers, because the waves keep going in both directions forever and ever. And the range for this particular function is from -1 to 1, and it includes -1 and 1, which is why I use the brackets. So this is the same as saying from -1 to 1. Okay, so the brackets mean that equal sign is underneath the inequality. Okay, so how do we take our sine and find the inverse sine? Well, if we think about what we learned above, we know that our domain and ranges are switched. So our range for inverse sine is going to be the range for sine is going to be the domain for the inverse sine. Now, before we fill in the range for inverse sine, let's take a little deeper look at the diagram. So, you'll notice that the squiggles for sine keep going, but there's one particular segment that is in the blue. Now, if we take that segment and we switch our x and y values, then what we get is the graph of inverse sine. And so we're not taking the whole picture of sine and flipping it over the line y equals x. We're only taking a small part of it. And so we need to think about that small part and what that tells us about the range. So again, range is the y value. So I can see here that my lowest y value is -pi/2. And the highest y value is pi/2. So even though the domain and range switch for the range of sine, when we think about the domain and range, domain of sine and the range of inverse cosine or inverse sine, it's not exactly switched. And that's where we need to be a little bit careful. Okay, let's take a look at cosine and inverse cosine. So for cosine and inverse cosine, we see something similar, where again, the cosine wave goes up and down and up and down, but there's a special part that's highlighted in the blue, and that's the part that we flip over the line y equals x to get our inverse cosine graph. Now let's look at our domain and range again. So our domain for cosine is all real numbers. But if I look at the range for inverse cosine, I can tell immediately that it's not all real numbers. The lowest y value is 0, and the highest y value is pi. Okay? So just like sine and inverse sine, the domain of cosine is not the range of inverse cosine. However, the range of cosine goes from -1 to 1. And that is exactly the domain of inverse cosine, from -1 to 1. So the domain and range sometimes switches, but where we need to be careful is that the domain of cosine does not exactly become the range of inverse cosine. All right, let's take a look at our third and final inverse trig function. Now you'll notice in the tangent picture that there's a lot of different branches. And the branches go on forever and ever in both directions, but I'm just going to take this middle branch right here. And this middle branch is what I reflect over the line y equals x to get my arctan graph. And if we look at the domain of tangent, it is going to be all real numbers except x cannot equal any integer plus pi over 2. So this is at pi over 2, this is at 1.5 pi over 2, negative pi over 2, negative 1.5 pi over 2. And so we'll put a plus or minus sign there to take care of both sides. Now this domain is not the range of inverse tangent. If I look at the range of inverse tangent, I realize the smallest y value is negative pi over 2, and the biggest y value is pi over 2. So my range for inverse tangent is negative pi over 2 to pi over 2. Now the range for tangent is going to be all real numbers. And that is the domain of inverse tangent. So we can say the domain of inverse tangent is all real numbers because the curve extends in both directions forever and ever. This domain is not that range, but the range of tangent is the domain of inverse tangent. So we're going to stop part 1 of the video right here. And when you come back for part 2, we're going to go ahead and take a look at some applications of inverse tangent. See you there.